Hello, this is video S. That was S. And yeah, we've crossed the line. We're in object-oriented programming now, and it's a big deal. That's why we named the course after it. And this is a continuation of the last video, but with a concentrated effort not to make it as long as the Star Wars trilogy. I'm going to try to keep these videos shorter, and you can keep me honest by complaining if I don't. But in video S, we're going to start with what we ended with last time. Well, first of all, I'm going to label this discussion. This is going to be levels of abstraction. Abstraction in OOP. That's a long title. But it's still an introduction to the big ideas of OOP, and you might think, well, when are we going to get to the code? Just tell me where the curly brackets and the semicolons go. There's more to this class than this. It's not just getting the program assignments in, even though it might feel like that. It's understanding what's going on. And the more you understand sort of the big ideas of why we're even writing these programs in the first place, then I think the simpler it's going to be to actually get her done and get the programs written. And certainly it will be easier to understand what on earth is going on inside such a program. And we're not going to have a short video if I keep talking like that. Abstraction. I think I threw that word around a lot in the previous video, did I not? You might think that's art that you make by putting your canvas on the ground and throwing paint out the window. That's one kind of abstraction. But in computer science, and actually in art, it just got kind of, off track that way. But abstraction in computer science means you just ignore the technical details. You do focus on the big ideas. So what we're going to do is initially get rid of all those nasty technical details, where the semicolons go and the curly brackets and all that stuff, and just concentrate on the big ideas. At the highest level of abstraction, most of the technical details stripped away. I'm going to try to spell words correctly too. H-I-G-H-E-S-T is the ADT. ADT. Abstract data type. And it might have confused you last time that an abstract data type doesn't really involve any data. That's what makes it abstract. The data itself, those are vulgar technical details. Let's not worry about those when we're talking about ADTs. An ADT, you can define it simply as a set of operations. An example, you know what? I'm going to do the examples in a different color. Example, TV. A TV. And I'm going to put that in quotes. By hand, it's air quotes. TV. Why is that in quotes? Because I'm not talking about a concrete object at this point. When I say TV, I'll venture to guess that every single person in the studio audience watching this video immediately has some idea of what I'm talking about with the TV. This is an acronym. It's short for television. But a TV, let's see. That's the thing. Well, first of all, you got to be able to turn it on. You turn it on, you watch it, you listen to it. If you got the sound on, you're not busy. Maybe you flip it through the channels. Maybe you increase the volume, decrease the volume. Listen to how I'm describing that TV. That is all just a set of operations. I am defining what it means to be a TV by what you can do with it. Notice, nowhere in that little list of what a TV is did I say anything about LEDs or plasma screens or old school tubes, tube-type pictures, circuits, all that stuff. That's the gory technical details that we're leaving out at the highest level. At the highest level, you focus on just, okay, I need a thing like this. I need a data type that I can do these things with. How that's actually implemented, I don't care about that. That's for the piddly little minions in the cubicles. I'll let you worry about all that stuff. How to actually implement this. I'm having the big ideas. I'm looking at the big picture. In C++, in yet a different color. And I think I'm actually using the board the way I might have intended. It's not going to look like my picture, but that's okay. At the level of the ADT, we're not talking about should it be an array, should it be a structure, do I need functions, all that stuff. All I'm thinking about is what I need to be able to do with it. In other words, the operations themselves. And I'm going to say at this point, specification, if I can spell that, specification, specification, design, description of operations. Specification probably should have been slashes rather than commas, but it's okay. Specification, design, description of operations. You're deciding it would really be nice to have a data type that could do these things in my program. So either I'm going to write it or somebody else is going to write it, but we've decided, yeah, we really want an abstract data type that can do that. Okay? Now, the next level down, moving downward. Let's go from highest down to lowest. The next level down, and I don't mean that it's less important, absolutely not. Moving the next level down in abstraction means I'm gradually introducing some of these technical details that I left out at the lofty level of the ADT. This is on high, and we're going to get down and dirty before we're finished with the whiteboard here. At the next level down is what's called a class. Oh my goodness gracious, here we go. Class is one of the hardest working terms in C++ and object-oriented programming. A class, in this sense, it actually is very much like our class, a collection of students. Technically speaking, a class is a collection of objects. If you have a bunch of fish objects in your aquarium, then your aquarium constitutes a class of fish, because you've got a collection of objects that are all the same type. Now, unfortunately, not only does it mean that when we talk about it abstractly, it's also a reserved word in C++. It also is a thing, a language feature that means here I'm going to define what objects of this class are going to look like. In other words, we're getting serious about actually trying to implement this data type so we can use it in programs. The TV level, which is horrible red here, this would be, what would it be? This is going to be a technical diagram, tech for short, tech diagram for making a TV, or building a TV, whatever you want to say, for making a TV. If this were a building instead of a TV, blueprints, that might be a word you're familiar with. We're laying out the schematic. We're describing how this can be done. We still haven't done it. If this, here's another example. I'm not going to add another column. But if this is a cookie up here, I just say cookie. Everybody had their own idea of what a cookie is. Maybe chocolate chip, maybe that's your favorite, maybe oatmeal, maybe something fancier. I'm going to get a little more specific in my ADT and say a gingerbread person, a cookie. A gingerbread person cookie. Here's our cookie cutter and our list of ingredients. So this constitutes like the pieces we need, the ideas that we're going to need to actually make this real, make it something that we can actually use. If it's a cookie, something we can actually bite and chew and swallow. That's going to be our goal down here at the bottom when we get to something very specific. In C++, that overused word, I'm sorry, class. It's class over here in the abstract description of levels of abstraction. It's class. These two classes are different. This is talking about a collection of objects, or how we would design those objects, a plan for making those objects. This is an actual C++ syntax feature. A class is a thing, just like a structure is a thing. And actually, that's going to be my description of it. A class, in the most vulgar terms, but the most easy to understand, is a structure with functions in it. Why didn't I just say that to start with? Well, actually, this is how we actually set one of these more general, lofty idea things up. We'll have a C++ class, which, when all the smoke clears, is going to look very much like a gigantic structure that has not only all the fields in it that we need for an object of that type, it's also got a bunch of functions in it too. And we'll see why those are all put together into one big thing called a class, rather than just using a structure and passing that around to all the functions like we did in program 2, or whatever program if this is the class of the future. I used class there a different way, and I'm sorry about that. Okay, now that's the highest level. We've now reached the bottom, the dregs, the bottom of the C. Object, and I just this instant realized that that also has been overloaded. In other words, it has more than one meaning in the context of this class. We've seen object before when it's talking about the binary version of a program that you wrote in object code. Oh, no, unfortunately, that's not what this is. An object is a thing, a tangible, real thing. So if we're talking about a TV here, at the object level, TV in quotes was the general idea. Everybody knows what a TV is, what that's supposed to do. A technical diagram for making a TV. That's actually sort of all the plans we laid out and all the pieces. Now we put all those together, and I'm going to say this is the TV in my living room that my dogs are watching. You can't get more specific than that. That is a specific object that was built by somebody, not by me, built by somebody using some sort of technical diagram, factory plan, whatever it may have been, based on this lofty goal up here of what a TV ought to be. You might think this is useless up here. This is just so in the clouds. But actually it isn't at all. The specification, design, description of operations, a TV. In other words, we list out all the things. It's almost like a wish list or a to-do list. We list out all the things that you got to be able to do if you want to call yourself a TV. You got to do this. You got to be able to change the channels. You got to be able to watch videos or whatever you want to call them, TV shows on TV. All those things. So this is a checklist. This is a design to make it happen, the class. And then this is the actual things that you can do something with, that you can do those operations to. And over here in C++, this is a specific, S-P-E-C-I-F-I-C, variable, V-I-R-I-A-B-L-E, that has this class as its data type. A lot of writing. Sorry about that. A specific variable. So now we could have a TV data type that we set up. We decided we needed some sort of a representation of TV in our C++ code. We'll talk about it. We'll discuss it with whoever else is working on this project. And we'll come up with a specification or description of all the operations we need if a TV object is going to be a legitimate TV object, self-respecting object that can do all this stuff. Then we get to the level of designing the class, a structure with functions in it. You might remember that weird little thing I said about structures. All it is a design. It's like a mental note through the compiler of a new data type. It doesn't take up any space in memory yet. Not until we use that structure, dog structure, team structure, or whatever it may be, not until we use that to actually set up variables. Do we have any memory space occupied that we could fill in with field values and all that stuff? So this is the same thing on steroids, more or less. I mean, you can even use a structure if you want as an analogy for this. It's pretty much the same. We design the structure. These are things we need to know about a team. We set up the team structure at the top of the program so that we can use that to define variables. And then we actually define the variables in an array or separate structures, whatever it may be, so that we could use them in a program. It's the same idea here, except as we're going to find, these tend to be a lot larger and unfortunately a lot more complicated than structures. I didn't mean to scare you. I'm sorry. I take that back. Erase that part of the video. Back up. Now, I've got highest over here, so I need to also move down to lowest. And again, that's not lowest in importance by any means whatsoever. We're not even using it at all until we get down to this level. Concrete level. This is the least concrete. This is without form and void and just kind of up there in the clouds. This is the most concrete. This takes up space and memory. Why do we need both of these? Well, this is a description, more or less, in C++ of what this data type is going to look like if we ever get around to defining variables of that data type, for crying out loud. If we do, As soon as we start using our new homemade class that we've written in C++, as soon as we start using that to make variables, then voila, we are at the object level. Each one of those will be an object of that class. And yes, a lot of this is just to try to drill those terms into your head. Oh, I lost track of my cookie. Cookie, gingerbread person cookie. There. We've all got a mental image of that. It's abstract. Was it Plato that did the same thing with the chair? Said when you say the word chair, then everybody has their own idea of what a chair is, but that's not concrete at all. It's not a chair you can sit in, not the idea. Here's the idea of a TV in air quotes. Here is a plan for making the thing based on all the things it needs to be able to do. And here's the TV in my living room. I lost the cookie again. Darn it. I should have written a separate column. Gingerbread person idea. Gingerbread person cookie cutter with ingredients and everything. You still can't eat it. This is a gingerbread cookie with the left leg bitten off that's in my refrigerator. Not really. I'm sorry. I wouldn't do that. That sounds cruel. But this is a specific cookie that I made using this plan based on what it meant to be a gingerbread person cookie. And I filled up the complete whiteboard, and I promised I was going to chop off videos. So you know what? I don't even care how many minutes I'm taking up. That's the end of this video, and I'll see you online.